Hello guys, Mr. G here with another video for the grade 12. We're going to finish and we're going to do another two questions from the control test one that we were doing last time. So this time we're going to be doing questions 3 and 4. Question 3 is projectile, and let's start with the question. The question said a ball P thrown vertically downward with a speed of 2.5 meters per second. So we can to save some time, we can write here some data. So the initial velocity of P is going to be 2.5 meters per second downward. You can see is downward. So there is the direction of that velocity or that speed. At the same instant, another ball Q is dropped from the top of another building B. So Q, the initial velocity of Q is going to be 0. It's going to be dropped, okay? From the top of another building B. Building B is 4.9 meters lower than building A, and that one is showing the picture there. Both balls hit the ground at the same time, and this is an important data. The time they took to hit the ground was the same time. Ignore the effect of air friction and define the term free fall. Now, free fall, remember, is a motion for which the only force acting is the gravitational force. Let's get the definition here. And the free fall is a motion for which the only force acting on an object is the gravitational force. Remember, only force acting is gravitational force. Very important. So make sure you don't miss those words there. Now, use only equation of motion to solve question 3.2, which means you cannot use any other option like energy or something like that. Calculate the time taken by ball P to hit the ground. So now we're going to start for ball P. So let's write here for P, because they want us to calculate the time for P. And we're going to use formula. There are different formulas. Let me show you here in the formulas that they are giving to you guys. Here are the formulas, all the formulas. Now, if we use these formulas, for instance, we have three unknown. We have displacement, we have final velocity, and we have time. So it is a little bit complicated to answer for that one. And same if we use that one. So the best option in this question is to use this formula here, because we will have only two unknown, the time and displacement, and we'll have to work simultaneous. Okay, so that is what we are going to do. So we are going to use that formula of displacement equal to initial velocity multiplied by time plus, let's move that one a little bit closer there, multiplied by the time plus half acceleration times square. And let's substitute what we have here. And then here we have in a two unknown, so we cannot carry on. We stop in here and we are going to call this one equation 1. We have two unknown, we cannot carry on, guys. So we are going to go now to ball Q. Remember, the time was the same, okay? So let's write here for Q. And let's work with Q. Same formula. We're going to use the same formula because the other formula, you have two unknown for both of them. And then here we are, guys. It's very, very simple. Now, note the following here. I want you to note something important. This one is equation 2, but something important, guys. I didn't write down positive, which I am going to do now, but I didn't do before because the whole motion of both balls is only downward, so everything is down. So it was not necessarily to write down positive, but let's do it because we always do it and it's quite important. Remember, the object is only moving down, so there's no reason for us to write it down. However, it's important. Now, what we need to go back to the question real fast. and I want you to see something. The displacement for ball P here is this one. This one is the displacement, it's a vector that is going down. That is the displacement for P. Now the displacement for Q will be only this one here. This one is the displacement for Q, but we have to quit because we have too many unknowns. So how will displacement for a Q be equal to the displacement for V? All right, the only difference is this distance here. This distance here is the difference between the two displacements. So displacement for Q will be equal to displacement for P if you add the 4,9 meters. That is what I want you to know. So displacement P, let's write it on this side here. Displacement P is equal to displacement Q if you add 4,9. That is quite simple here and is very important. So now here back, that is an important detail. Displacement for ball P will be equal to the displacement for ball Q, but you must add 4,9. Alright, so saying this, now we can substitute this one in the equation here. Remember, this one was for P, so we can substitute there, guys. That's all we have to do. The question is not that bad, guys. So let's substitute quickly there. Displacement P is going to be now displacement Q plus 4,9 equal to, and then the rest that we have there, 2,5 delta T plus 4,9 delta T squared. And we are there. This one is just now some calculations here. But remember, we still have to substitute the displacement here, so that is equation 2 will be 4,9 delta T squared plus 4,9 equal to 2,5 delta T plus 4,9 delta T squared. And now we have everything here, guys. So you can see now it's a very simple equation to solve for delta T, and then you can see there that the 4,9 T squared will cancel each other. And then when you solve this one, you have 4,9 divided by 2,5 is going to be equal to the time. And then the time is going to be equal to 1,96 seconds. This question is not that bad. It's not always been the question like this, so it's kind of new, let's say. Was not such a question. We did have question of two objects moving up, both of them down, or different things, and we get the idea, but not exactly the same like this one. So let's go to the next question now. So now they said calculate the speed with which the ball Q strikes the ground, and now you have all the data, so it's quite easy. You're looking for speed. So what is the best option to calculate the speed? We have now a little bit more data. So guys, the easiest formula is final velocity equal to initial velocity plus acceleration multiplied by time. We have the time because it was the same time. So if we substitute here for Q, remember we're working with a Q here is 0 plus 9,8 multiplied by 1,96 there, and the final velocity is going to be 19,21 if we round off to 2 decimal places after the comma. This is the final answer for this question. Okay, the final answer for this question. And then to finish the question on projectile, they asking you to draw the graph. So 3 point is going to be question 3.3, and that is to draw a graph. And the question said, on the same set of axes, sketch the velocity times graph for the entire motion of both balls P and Q. Label the graph P a Q and indicate the following in your graph. Speed with which ball Q strikes the ground and time at which ball P hits the ground, which is the same time. Alright, so here we are. Let's start with P. Now, the initial velocity for P is 2,5. We're going to say down positive for the graph as well. For the whole motion, we use down as positive. So starting from 2,5, this ball moved all the way to the ground and it took a total of 1,96 seconds to reach the ground. 1,96 seconds to reach the ground. Now ball Q was dropped, so starting from 0 and is moving all the way parallel to this one up until also the same time, because that is the time taken for both balls. But they say they want to know what is the final velocity or speed of this ball Q, and that one is going to be 19,21. It was calculated there. This one here is Q, this one here is P, and with this, guys, we are done with question 3. Let's go and look question 4. Now here we are. Question 4 said, a man on roller skates having a combined mass of 87 kg moving horizontal at constant speed in a straight line sees a boy of mass 22 kg standing directly in his path. The man grabs the boy and they both continue in a straight line at 2,4 meters per second. Ignore the effect of friction. State the law of conservation of momentum. Calculate the man's speed just before he grabs the boys. And is the collision elastic? Use calculation to support your answer. This question is not that bad. We've done many more questions that are much more difficult than this one. But let's answer this question real fast, guys. Okay, so question 4. Question 4.1 for studying the law of conservation of momentum. Guys, you have to read carefully. When I was marking, some questions answer the definition of momentum instead. So they're asking you for the law. The total linear momentum, word total is quite important here. You cannot mess the word total. Linear momentum in an isolated system remains constant. So the total linear momentum in an isolated system, the system must be isolated, remains constant. Okay, so now we can answer question 4.2, which is calculating the speed of the boy just before grabbing the other boy. Okay, so let's see here quickly what is happening. There is a boy that is moving in one direction. In this case, they said moving horizontally. So they don't really say direction if it's right or left. It's moving in a horizontal direction, okay, in a straight line. So we're going to say that it's to the right. It's moving. It's moving. In C, he sees another boy who is not moving. The initial velocity of the second boy is 0. So we're going to call this one boy 1 and this one boy 2. So the initial velocity 2 is 0. And then the two boys combined are going to be moving together. And the velocity of both of them is going to be straight line, still in that direction, or continue moving in the same direction, and the velocity there is going to be equal to 2,4 meters per second. Now they give you the mass of the boys. M1 is going to be equal to 87 kilograms and M2 is going to be equal to 22 kilograms. It's a small boy. Okay, so this is what happened before and after, and we are going to use now the law. Now for the law, we're going to start saying that the change in momentum is equal to 0. We're going to start from here. There is more starting point, different one, but we're going to start from there, and we're going to say that the initial momentum 1 plus the initial momentum 2 is equal to final momentum 1 plus final momentum 2. This is where we're going to start. Then we say that mass 1 multiplied by the initial velocity 1 plus mass 2 multiplied by the initial velocity 2 is equal to mass 1 final velocity 1 plus mass 2 final velocity 2. Okay, so let's substitute what we have. Note the following, guys. This one here is a common factor because you can see that they moving at the same speed, final, and then you can add the masses 1 and 2. You can do this one at this point, or you can just substitute everything. So in this case, what I am going to do is to substitute everything. And then the final answer here is equal to 3,01 if you round off to 2 decimal places after the comma. That is the final answer for this question. Now the next question, I ask you if the collision is elastic or inelastic, and you have to prove it. So now, how you do this? Remember, to identify a collision, the difference is the total kinetic energy. So if kinetic energy is conserved, then collision is elastic. If kinetic energy is not conserved, then collision is inelastic. So all you have to do is to calculate the kinetic energy total for initial and the kinetic energy total final. That is all you have to do here. And let's do really fast this one here. The answer here is 394,11 joules. So now for the second one, K total final, and I'm going to already write that on there. And this one is going to be 313,92 joules. You can see now that the total kinetic energy initial is not the same as the total kinetic energy final. You can see that one, they are different numbers. The answers are this one and this one then. Therefore, collision is inelastic. And with this one, guys, we are done with the 2 questions we had planned to do today. That was a momentum question and that was a projectile question. Next time we're going to be doing some organic chemistry. Here we are. So please don't miss the video. It's going to be a good video. It could be confusing things. So we're going to be looking at the organic. There is a graph of physical property. We're going to see how far can we go with the 3 questions of organic, so we don't have to make another video. But remember, I don't like to make videos too long. But guys, thank you for watching. I hope it helped. If it helped, please subscribe for the channel. Time up, and I'll see you next time. Mr. G here.